Okay, in your homework you have a ready that starts you out with predicting whether a relationship is direct or inverse variation. If you remember, direct variation is when something increases, the other thing increases. So if your independent variable is increasing, your dependent variable should be increasing as well, or vice versa. If your independent variable is decreasing, then your dependent variable should be decreasing as well. Inverse variation is the opposite. So as one variable increases, the other decreases. So if independent is increasing, dependent should be decreasing, and vice versa. If independent is decreasing, then dependent should be increasing. So let's look at our situation. The number of times you wash your hands and the number of times you get sick. As the number of times you wash your hands increases, the number of times you get sick should decrease. So that means that we have an inverse variation on our hands. If we look at this situation, the number of houses a maid cleans and the amount of money she makes, then we should be seeing that as the number of houses a maid cleans increases, the number of time she gets paid increases, and so the amount of money she makes increases. So that should be a direct variation. With these two examples, you should be prepared to do the rest of your ready on your own. Then in the set, we're looking back at what we did in class today, looking at inverse variation functions in context. In our context in class today, we had rate equals 27,393.82 kilometers over time, talking about tsunami distances and rates. And we generated this table showing that as time increases, our rate is going to be decreasing. And so the first question, so the graph that we get is right here, and the first question that we're asked is, what units are involved in the problem? Define the quantities and variables you would like to use to model this situation. Well, in our situation in class today, we were looking at a rate based on the time. So if you chose hours on your time, your rate would be kilometers per hour. If you chose seconds on the time, your rate would be kilometers per second. So on here, you've got time at seconds or hours or minutes, whatever you chose in class today. And then on the y-axis, you have rate, which is going to be in kilometers per time unit that you chose. So kilometers per second, kilometers per minute, kilometers per hour. And that's all that question is asking us to do. Then the next question really focuses on the graph that they give you, which is the upper right-hand quadrant. And it's asking you what type of function does this relationship represent. So it's going between direct variation and inverse variation functions. And so as we increase in our time, our dependent variable, our rate, is going to be decreasing, which we can see both in the table and on the graph. And so for that reason, we can say that it's inverse variation, the same way that in the Go we said it was inverse variation. Finally, it asks us what would be the rate of the tsunami at time 100. And so we plug in this time 100 into the time location. And so you would see an equation such as this: R equals 27,393.82 divided by 100, which gives us 273.9382 kilometers per second. If your unit was kilometers per second, it would be kilometers per hour, etc. Depending on what you chose. Just make sure your units match. So if they said 100 seconds, it would need to be in seconds. All right, now looking at the Go, we're doing properties of exponents today. So if you remember correctly, x to the fourth times x to the negative sixth is multiplication with the base being the same. A negative exponent means that we're dividing by that many bases, so x, or dividing by x 6 times, and a positive exponent means we're multiplying by that number each time. So what that looks like is this: x times x times x times x divided by x times x times x times x times x. So 6 x's in the denominator, 4 x's in the numerator, because we have a positive 4 and a negative 6. Then you can simply cross out the x's that match because they divide out to be 1, and that leaves us with 1 over x times x, which we can simplify using exponents as 1 over x squared. We tend to like our exponents to remain positive, but just in case you're wondering what this means, it's also the same as x to the negative 2. Next, we're going to look at a to the negative 2 times b to the 4th, all of that squared, the quantity squared. And so what this means is we're going to be multiplying this entire thing, all this stuff in the parentheses, by itself twice. So I just wrote it out as itself being multiplied twice because that exponent says 2. And then we're looking at what this means. So we have 2 positive exponents of 4 and 2 negative exponents of 2, and so we're going to be multiplying by b 4 times and then another 4 times and dividing by a twice and then another twice. So that will look like this: b to the 4th times b to the 4th over a squared times a squared, which if you write out from the meaning multiplied by itself that many times, you have b times itself 8 times and then a times itself 4 times, which can be reduced to b to the 8th over a to the 4th. Finally, if we look at the fractional exponent r to the negative 1/4 example, the fraction, if you remember from Unit 5, is going to convert to a root, a 4th root, and so the denominator of the fraction will be going into the root of the radical, and then the base will remain the base inside the radical, and the exponent will be the exponent of negative 1, and that gives us an r being divided by itself 1 time, and so we get the 4th root of 1 over r. So that should prepare you to be able to do the go all by yourself. Good luck!